Hi everyone. As we continue to talk about some of the basics of Big IP, I wanted to take a few moments to go over a concept on the Big IP called self-IPs. There's two different types of self-IPs. There are static self-IPs and there's also floating self-IPs. A static self-IP can only reside on a single Big IP device, whereas a floating self-IP is typically shared amongst devices in the HA pair. The functions of the static self-IP are to provide health monitoring. So that static self-IP is what's actually sending all the health monitors to a backend application server. The floating self-IP is what's actually used for the IP address translation when the client connects to the virtual server. It is not the client's IP address that's sent back to the application server. This would most likely cause an asymmetric routing scenario. So that's why we do address translation, also for security purposes. So to better give you an idea, let's go to a Big IP. Let's navigate to network, and we'll navigate to self IPs. You'll notice I have three self IPs here, but we're going to focus on our internal self IP, and then also one that's represented by internal self IP float. If we go ahead and select this IP, you'll notice that it's represented on the internal VLAN, and it is currently on the non-floating traffic group. So this is how we can actually identify a self IP address as being static, is not being shared amongst an HA pair. If we select the other self IP, you'll notice that it's also represented on the internal VLAN, but it has a traffic group of traffic group 1 floating. So that would simply mean that it can reside on multiple Big IPs, it being active on the active Big IP itself. So in the event that active Big IP goes down, this floating IP address will now be active on that secondary or standby device. Now let's go to our virtual servers and let's look at how address translation occurs. So one of the most common scenarios that I run into with an experienced F5 administrators is the asymmetric routing scenario. And the most simple fix is enabling source address translation Automap. So by simply configuring Automap, this allows the virtual server to perform address translation for the client to the application server. So this will actually be represented by the floating self IP. Now if we take a look at our pool, we'll notice that we have a health monitor, a custom website monitor, and this check will actually be performed by our static self IP address. So let's go ahead and see both of these in action. We're going to do a TCP dump for our static self IP. And here you will simply see our HTTPS health monitor. Self IP, our static self IP, and our internal application server. Now to show our floating IP address and address translation, let's first go to our client, identify its IP address, run a TCP dump using that client IP address, using a switch of :np, which allows us to see both the client side and server side during a TCP dump. Go ahead and kick that off. Go back to our client, launch the browser, Let's go back to our TCP dump. Scroll up to see where it kicked off. And you'll notice here the initial request from my client to virtual server. Communication continues between client and virtual server. And because I have the authentication piece, it took a little bit. But now you'll notice communication from our internal floating self IP address to our application server. Nowhere in this communication stream will you see my client IP address communicate with the backend application server. So as an overview, there are two different types of self IP addresses: a static self IP address and a floating self IP. A static self IP is performing our health checks as we identified in our TCP dump. And then our floating self IP is used when configuring Automap on our virtual server. And it's performing the IP address translation on behalf of the client in order to communicate to the application server on the back end. Well, I hope this helps someone out there. Until next time.